Dobre dan, and warm welcome also from my side. Simon, thank you for the introduction. And I'm pleased to tell you something about the technical challenges and innovative solutions for integrating solar thermal into district heating. Is this connected or not? Just a short presentation of my company. Solid, we're an Austrian-based company operating for almost 26 years, and we are specialized in solar heating, solar process heat, and solar district heating. We are project developer, constructor, and operator of solar systems and have realized more than 300 projects. Currently, we work in 3 offices. Additional to our home base in Graz, Austria, we are in the US, in Singapore, and in Germany. As we heard the last days, extensively, that of the total global energy consumption, more than 50% is corresponded to heat, where transport or mobility and power are the other 50%. So there is a huge effort to make in heating. I've realized personally in the last years, especially in Germany and in Austria, that it's mainly talked about electricity and about transport, but now there is a change and people are talking about heating. District heating is quite a good infrastructure to include and incorporate renewable energy sources, but till today district heating systems are mainly based on fossil fuels. As you can see here at this chart, is that the main resources are coal, oil, and natural gas. Renewable energies are still a minor share. Also here in Serbia, it's mainly focused on mazout, heavy oil, gas, and coal. But in future, we need to make a change, and I doubt that there will be the golden technology which changes everything and which can be used anywhere at all time. So therefore, there will be a mix of energy in future, especially in urban dense areas, based on its local and regional conditions. Different technologies will be used and need to work together. As you can see here, this could be a future energy mix for an urban city, but each of those technologies has upsides but also downsides. For instance, the heat pumps, which are currently very prominent here in Austria for single houses, are still limited, are used with still limited renewable electricity, because basically the heat pumps are operating in winter, which are mainly still fossil-fired. Wind energy is a very good technology, but in order to cover current energy, there is still much more wind power needed. Waste to energy, for instance, recycling is getting modern and more effective, so recycling reduces the energy from waste. Biomass, sustainable biomass is still limited and differing between regional bases. Industry surplus heat is also very interesting and needs to be included, but also industry is trying to reduce their waste heat, so they try to change their system as well. Co-generation plants are mainly electricity driven, which does not match the heating profile. Geothermal, we had an interesting presentation earlier, is interesting but still also limited depending on the region where you are. And then there is solar thermal, where I will talk about. There is this seasonal mismatch between demand and supply. Basically, if you can see here, a load profile, solar district heating or basic solar district heating is focused on covering the heat demand. What does this mean? Here you can see a load profile of a regular district heating grid where you have the peaks in winter. I hope this presenter works. No, doesn't matter. Where you have the peaks in winter and low demand in summer, which is mainly the domestic hot water. Basic solar district heating, just focusing, and the solar thermal systems are, let's say, designed to cover the summer demand. However, what we call big solar is by, sorry, there was a different slide, okay, is basic solar district heating is focused on covering the domestic hot water demand. This is a rather technology which already exists, is nothing innovative and works. For instance, where I'm from Austria, we have realized 20,000 square meters in the city of Graz, which is currently in operation and covering part of the domestic hot water demand in summer. As you can see here at the Fernheitswerk Graz, this was one of our first projects, initiated in 2007 and currently has more than 8,000 square meters of collector field working there. Very interesting at this project is that we have a minor collector field of 2,000 square meters where we are testing different collector types from different manufacturers under real outside weather conditions. Since we are not a manufacturer but a system engineer and a constructor, we try to look in a research project which is the best collector used for the best scenario. Coming now to the thing we call big solar, which is the difference to the basic solar district heating. By implementing a seasonal storage, produced heat in summer can be shifted into the transitional and even winter period. So by incorporating a seasonal storage, solar district heating could have a large impact on the district heating systems. The basic concept of the big solar concept consists of three main elements, which is the collector field, the seasonal storage, and the heat pump. Mainly, solar heat is integrated into the system directly into the grid or via seasonal storage when sun produces heat but is not needed by the grid. The seasonal storage either also directly feeds into the grid or via heat pump, meaning that when the seasonal storage is partly empty, the heat pump has a key element in it because it could lower the temperature within the storage, lower to the return temperature of the district heating grid, which means is also in favor for solar heat. So lower solar heat can already be fed into the storage. So the storage could be emptied from 90 degrees Celsius down to 15 degrees Celsius. Without using a heat pump, you're always limited to the return temperature of the district heating grid. The heat pump is a thermal driven heat pump and therefore a high temperature heat resource is necessary. This could be a biomass boiler, a current already based gas boiler as we have in Pančevo, or anything else. Additionally to current sources or by implementing big solar to current district heating systems, such as a heat boiler, the heat pump can also be used for flue gas condensation of the boiler in order to raise efficiency. I just want to show you other potentials with high solar coverages. Denmark, for instance, is the pioneer in solar district heating and in large solar thermal systems. As you can see here, for basic solar district heating for summer in Silkeborg, this is the current largest established solar district heating system with almost 160,000 square meters, which is covering nearly the whole hot water demand in summer and has a solar coverage over the year of 20%. Another similar big solar project is in Boyens, which covers almost 50% of the energy demand in the city of Boyens and has a collector field of 70,000 square meters and a seasonal heat storage of 200,000 cubic meters. However, compared to Central Europe or also to the Western Balkans, Denmark does have different framework conditions. On the one hand, on organizational speaking, district heating is very well developed, meaning that also small communities with 5,000 to 6,000 inhabitants have already established a district heating grid. On a technical way, the district heating is on very low temperature, between 40 and 60 degrees, meaning this is in favor especially for solar thermal energy to be fed in. Another thing is that also there is another heat load file, let's say. Winters in Denmark are milder and summers are also milder, meaning that hot water demand is in summer a little bit higher than, for instance, for Austria. Another issue is that the availability of free land, especially at those small communities, there you don't have that much problems getting land, which is different to urban regions, for instance, like here in Belgrade. And last, also for implementing the storage, there are very easy soil conditions, meaning that the underground is mainly gravel or some sand, and the technical design for the storage is very simple and easy to conduct. There are also some framework conditions on the economics. For instance, that there are very high taxes on fossil fuel-based heat generation, so it's easier to get for renewables to get in. So, but looking at a solar potential map, Denmark has a large amount of solar heat, but the potential is not that big. As you can see, it's between 900 and 1,000 kilowatt hours per square meter. When we go to Austria, we have a little bit more, I would say 15 to 20% more, up to 1,200 kilowatt hours per square meter. And looking at Serbia, this is even higher. So Serbia has, compared to Denmark, 40% more solar potential, which is very interesting. Since solar cannot only be used for district heating or for heating itself, it could also be used for cooling. So this is easier to conduct. We are actually working different big solar projects or on different concepts. The one is in Pančevo and Por, which was presented yesterday by my colleague. And I just want to show you that since such a big solar concept has to be seen as an infrastructure project because it is complex. So a lot of steps are needed to take in order to guarantee successful implementation and also to guarantee good operation over its technical lifetime. So there are different phases which have to be done. First, the concept for the city or the municipality has to be developed. This means everything has to be analyzed. Then a design is being made. After this design, the whole engineering process has to be done. Then there will be the project realized, and then it goes in operation. And on each of those phases, very important steps are to make. We defined that we made different parts of it, and for instance, what we're doing in Pančevo, or what we have realized, is that we have developed the concept, analyzed its potential, and finished the pre-feasibility study. In future, there will be a follow-up study, and then the goal is to construct the project and operate the project. So, what are relevant success factors and challenges for integrating solar thermal heat? Of course, the district lowering the grid temperatures, especially in Central Europe, with relatively high, or the bigger the cities are, the higher the temperatures are. This is often problematic for solar heat. So the lower the temperatures are, the better it is for solar thermal. Till now, our feasibility studies showed that solar thermal is competitive to the current heat supply, but till now there is still some misconception about calculating costs. If taking into account the life cycle costs of a gas boiler, including buying the gas and everything and demolition, solar heat or solar systems are perfectly competitive. But they do have high upfront costs. But operational costs are low because there is nothing or little work to do, and the sun is for free, so I don't have to buy all the time something. Another very important factor is, of course, especially in municipalities and dense urban areas, is land requirement. So it's very important that thinking about land is part of urban planning, because it's a heat infrastructure which needs to be accounted. Also, it is possible to use areas with restricted possibilities, for such as a landfill or a protection zone, water protection zone, for putting the collectors on it. For the storage, this is another story. Another point is that the integration of a seasonal storage, but also the integration of the heat pump, leads to additional benefits. For instance, the storage for such a concept could not only be used for solar, but also for peak shaving of the grid, or for integrating CHP waste heat. And as I showed you at the other concept, also for flue gas condensation by an existing boilers. So what are important tasks for boosting solar in the Western Balkan? On the one hand, it's very important to make investments into the grid, because I can have the best heat production system. If I have a bad grid, this doesn't work out. So improvement in the district heating grid is important, to have refurbishment of the pipes, to automatization the substations, in order to increase efficiency of the system at all. Also, energy efficiency measures in buildings are important. Then we have realized in our projects that in the Western Balkan, district heating is only used during the cold season, let's say it like this. District heating is not used the whole season, so it's only mainly from beginning of October to April. By incorporating or by letting run the district heating system the whole year and trying to cover and increasing domestic hot water in summer, this is also potential, because now, especially in the Western Balkans, domestic hot water is mainly used or mainly supported by electricity. As I said before, land available as part of urban planning is also very important. Another important issue, what is also on my mind or on my heart very deeply, is that we make some capacity building, because not everyone knows all those different technologies. We are here now sitting and we are some kind of experts, but also the broader public should understand what are the challenges we have and how we could fix those things. So capacity building, especially for solar, but for all renewable energy systems, is very important. And of course there should be some funding options like we had now with EBRD, where we can focus on some concept development and look for implementation of such projects. Coming to my last slide, to summary. To summarize, big solar has a huge potential and can contribute to decarbonize the district heating significantly. There are some realized projects in operation, but those are mainly in small municipalities, so the next step is to go to urban dense areas. Several projects in Austria, but also in the Western Balkan, are in this development process, but they will take some time. The technology is ready to go, but of course, especially at the seasonal storage, it will further improve the next years. And lastly, institutional requirements are necessary for securing the land, also for the public authorization process, since till now nothing has been done like this yet. Funding options are necessary and the capacity building. So thank you for your attention, and I look forward if you have some questions.
Thank you, Patrick, for this very comprehensive overview of your activities and as well the process of getting those projects on the ground. One question popped during your presentation. This process seems to be very data-driven. How do you access data in cities to conduct your studies?
Of course, our most important part is to work with locals and to be connected with the district heating operators, because they know their system, they know what they require. Of course, we also need city officials for finding the land, but basically the first step is analyzing the district heating system, and this needs to be done by locals and by the district heating operator.
Regarding solar thermal, one of the key aspects as well often is to provide credible information on the solar resource. How does your company manage this aspect when you are entering the final stage of a project development process? How do you ensure you have credible information?
I didn't understand the
you mean
the aspect.
How do you measure solar resource in a credible manner?
Of course, this map I showed, this is only to get a realization. In the whole design and development process, we make firstly static. We design the system and make static calculations, and after that we make a dynamic simulation, system simulation, by using weather data from the past, which is quite a lot of weather data, also some forecasts, and also we incorporate the system with a simulation, let's say it like this.
Thank you, Patrick. Maybe we have questions on the floor? Yes?
Thank you. I have one question, that what kind of technology you exactly use for the underground storage? So it's borehole heat exchangers, or so what is the technology?
Can you talk louder?
Yes, so for the underground storage of the solar, what kind of technology you use? So it's borehole heat exchangers, or what is the technology you use for the storage?
The seasonal storage itself is pretty easy. In Denmark, as it's been developed and constructed yet, it's nothing more than a gravel pit, which is, there is a foil in it. It's above groundwater, so there is no insulation needed, and on the top there is a cover liner which is insulated, and of course there is a heat exchanger for partly not using the same water in the system, but basically it's not rocket science. But of course this is in Denmark, where the local requirements, especially the geotechnical requirements, are pretty easy. This could differ in whole Europe. We have made analyzations or an analysis where if you have very high groundwater, then you need another concept than the Danish concept for the storage, and then it's getting more difficult and also more costly.
In terms of technology, of course, the underground thermal storage is prevalent today, but in terms of investigation, you have also as well thermocline, as well PCMs that are very active today in demonstration projects for solar thermal.
Can you please provide us the data and comparison between the price of heating energy delivered to the commercial buyers, comparing the solar thermal power plant on the one side and a plant that's running on natural gas? Please, can you express it in euros per megawatt hours of delivered energy?
I'll try. Of course, it's rather hard to, even district heating operators cannot assess the lifetime costs of a gas boiler, for instance, because the gas boiler is so old that they don't calculate it that transparent anymore. But for Pančevo, for instance, our baseline was to have a price of 35 euros per megawatt hour, which we can compete with. So we will be lower than the 35 euros per megawatt hour.
For commercial buyers.
But it always depends on the size. You cannot say. So I would say solar heat could manage to be between 35 and 45 euros per megawatt hour. But of course, you also have, which is not included, are costs for CO2 if you look at emissions trading, or also peak shaving in some system, because as the district heating system in Pančevo, they pay some kind of top-up in winter for covering the peaks. All this is not included in this. So I hope I have answered your question.
Also, maybe to position this, of course, you have to compare what is comparable. So the importance, as Patrick mentioned, is scale. So really assessing the scale of the project and comparing options versus ability to fulfill the demand in the district heating system. So very often the scale problem will be an issue, but we'll see as well later scale impact the cost. And of course, current and future cost at scale will be important to convince stakeholders to enter the project, which typically have a long life span. 40, 50 years is not unusual for those solutions. I see no more questions, so we can thank Patrick for his presentation.